Welcome student. Today our topic is tree. So today we will learn these contents of trees, introduction about tree, terminology used in tree, type of tree, binary search tree, traversing, and traversing is basically performed three way: in order traversing, pre-order traversing, post-order traversing, insertions in binary search tree, deletion in binary search tree, and insertion in binary search tree. Now, what is the tree? Tree is a non-linear data structure that is consist of nodes connected by edges. So, this diagram clarify the proper definition of tree. A tree always have the root. Root is that node which is the origin of a tree, and root doesn't have any parent node. Now, a tree is also set of subtrees. So, any tree which is left hand side from the root is known as a left subtree, and tree exists right hand side from the root is known as a right subtree. Each internal node basically have the childs, and last node which doesn't have the child is known as a leaf node. Now there are some terminology that is frequently used in tree. First one, what is the root? A root is a special node in a tree. The entire tree is referenced through it. It does not have parents. Now what is the parent node? Parent node is an immediate predecessor of a node is known as a parent node, and child node is all immediate successor of a node or its child node. Next terminology is sublinks. The nodes with the same parents are called as a sublink. And what is the path? Path is a number of the successive edges from source to destination is known as a path. Height of node. Basically, height of a node is determined from the number of edges on the longest path between that node to the leaf node is known as a height of a node. Next, height of a tree. The height of tree represents the height of its root node. And next, level of nodes. The levels of node represent the number of connections between node and the root. It represents generation of a node. If the root node is at level 0, then its next node is at level 1 and its grandchild at level 2 and so on. This diagram shows how we determine the level. So, the level of the root is always determined as a 0 or always represent like as a level 0. Now, next node, which child of root is always denoted by level 1, and this process continues. The types of a tree. Basically, there are 4 types of the tree: binary tree, binary search tree, AVL tree, and bit tree. So, we will learn one by one. What is the binary tree? Binary tree is a tree or a data structure in which each parent node can have at most 2 children. So, we can say any binary tree, any tree in which the internal node have at most 2 children is known as a binary tree. Next is binary search tree. Binary search tree is a data structure that quickly allow us to maintain a shorted list of numbers or data. So, in other words, we also can say a binary search tree always provide the shorted data, and basically it have 2 reasons due to which it is known as a binary search tree. First reason is that it is called a binary tree because each tree node have maximum 2 children. And second one is that it is called as a search tree because it can be used to search for presence of an element or data in a tree. So these two regions basically define such type of tree as a binary search tree. There are some properties of a binary search tree which differentiate a binary search tree from regular binary tree. So there are two regions which separate the binary search tree from the other regular binary trees. First one, all nodes of the left subtree are less than root node. It means value of left subtree is always less than root node value. Second point is that all nodes of the right subtree are more than the root node. It means in the right subtree the elements always have greater value than the root node. So both subtrees of each node are also binary search tree. They have above two properties. Now using this diagram we can clarify which tree is binary search tree and which is not binary search tree. Now here this diagram denote the tree is a binary search tree because it follow the all rules of the binary search tree. Here root is 8. Now all values left hand side are less than 8. So we can say the left side subtree all values are 1, 3, 6, 4. So all these data are have less value than root value. And in right hand subtree we can observe the all data are greater than root value because here are 10. So 10 is greater than root value 8. So we can say this is a binary search tree. Now in this tree we observe that when we insert or add 2, so this 2 must add at the left hand side of 3 because according to property of the binary search tree the lower value should always go left hand side, and here we observe that he go the right hand side of the node 3. So we can say that this tree is not a binary search tree. Now there are just some general operations which are performed on a binary search tree. First one is traversing. Traversing is also performed in three ways: in order traversing, pre-order traversing and post order traversing. And next three operations which are generally performed in binary search tree like insertion, deletion and searching. First one is traversing. In order traversing. What is the traversing? Basically accessing each element one by one in a tree is known as a traversing. In order traversing, we first go left most side and we access the left node. After accessing the left node, then we process the root node, and after root node we go right hand side to process. So that is the sequence in order traversing: left node, root node and right node. Similarly in pre-order processing, we basically first process root, then left node, then right node. And in post-order traversing, we first process left node, then right node and then root node. So this is the order of processing, traversing the nodes, and according this traversing mechanism their name is in order, pre-order and post order. So first one we text the algorithm how we implement the in order traversing. As you know, the order of in order traversing is a left node, a right root node and then right node. So this is the order of accessing or traversing the nodes in the in order. So first we make a procedure in order procedure and we put root left, because in this we always have to go the leftmost side and we process first the root left side nodes. Now, if root gets null, then we return, and after that we in order process the root, and when we process the root, then we print the info value or data value stored in the root. And after that we in order process the right hand side of the root. So that is the mechanism of processing in the in order traversing. Next one is pre-order traversing. In the pre-order traversing, we first process root, then left node, then right node. So this is the basically sequence of accessing the nodes in the pre-order process. Now, algorithm regarding to the pre-order processing is that first we process root, we use the pre-order process, and we find if root equals null, then we return here and we print the contents of the root, and after that we pre-order process the left hand side of the root, and after processing the left hand side we pre-order process the right hand side of the root. So using this algorithm we implement the pre-order traversing. Next and last traverse order is post order traversing. In this traversing, first we process left node, then right node, and after that we process the root node. So algorithm for this, we basically first post order process, we process the root of left, it means we process the left subtree and leftmost node, and we check the root value. If root gets null, then we return, and after that we process post order process traverse the roots right, it means we process the right subtree of a tree, and after that we process the post order process of the root, and processing the root we basically print the data value or info value of the root. So this is the way of traversing, and basically there are three types of the traversing: in order, pre-order, and post order. Now the general operation deletion is also performed on a binary search tree, and this operation basically implemented in three cases. First case is that in the first case the node to be deleted is the leaf node. In such a case, simply delete the node from the tree. In the first case, we basically delete the leaf node, and leaf node is that node which doesn't have any child. So that is the simple way of deleting. We basically remove the leaf node from the tree. Now in the second case, in this case the node to be deleted has a single child. It means the node in second case 2 we basically delete the node which have the one child, So such type of node is when deleted, then we use two steps. First, replace that node with its child node, and after that remove the child node from its origin position. In case 3, we basically remove that node which have the two child, and when we remove such type of node, we follow the three steps. First one, get the in order successor of that node. Second step, replace the node with the in order successor and remove step 3, remove the in-order successor from its original position. We consider case first, in which we want to delete the leaf node. Here leaf node are 1, 4, 7, 14. These are known as a leaf node. But our aim is to remove the node 4 from the tree. So that is the simple way for removing. We will cut this node from here, and our new created subtree will become such a way 1, 3, 6 and 7. So here our node 4 is removed from this tree. In the case 2, the case 2 is basically we have to remove that node which have the one child. So here suppose we want to remove the node 6. Here node 6 have the new child which is node 7. So we have to remove this. So when we remove this node, we have to follow 2 steps. First, we replace the child node with the parent node position, and after that we also remove the position of the child node. So here we remove the node 6, and when we remove the node 6, the child node will get the position here of the parent node, and after that we have to remove the positions of the child node. So the position is removed from here. So new created node is 1, 3 and 7. So here content nodes 6 is removed from here. Now case 3 of deletion. Here we basically remove that node which have the 2 children. So here we want to remove the node 3. Its 2 children are 1 and 6. So when we perform such type of the operation, we have to follow the 3 steps. First, when we remove this node, we always have to consider the in order processing. So when we remove this node, then we have to replace in order process element 4 to here. So this element will be shifted here, and our required element will be removed from here. So it is necessary to follow the in order processing. So in order processing, we have to shift 4 from here. We have to follow the 4 from here. Here we can see, observe here, 4 we shifted here, and these elements are there. Next operations which are generally performed in a binary search tree is the insertion. So insertion means adding the new elements in a binary search tree. So when we add the new element in binary search tree, we have to follow the property of a binary search tree. We cannot add the new inserted element in this unwanted position. Now step first we have to check if node equals to null, then we have to return and create a new data. In step 2, if new inserted data value is less than node data, in other words we can say the data value is less than the root value, in such a case we have to move the left hand side. So node will go left and insert node left to data. So in such a case we have to move the left hand side, and in left hand side we have to use the insertion procedure. We have to call insertion procedure again, and in this insertion procedure we have to shift data in left hand side. Else if data is greater than node data, it means data value is greater than root value. In such condition we have to move the right hand side. So node right will be use the procedure calls your insertion procedure call here, and we set the node in the right hand side, and there will be data will be set. Now we also can take an example here how we perform the insertion operation in a binary search tree. Suppose we want to insert element 4 in the existing binary search tree. So, when we insert this, first we have to compare our new element, that is our insertion element, that is also known as a key element, to the root. Here our root is 8. So, I will make comparison. So, I find the key value is less than root. It will provide me inform that we have to go left hand side. So, I will go left. In the left, I again get a node 3 and I will compare the key value with this new node. Here I find that key value is greater than existing node, then he will move from right hand side, then I will go here right hand side, and in right hand side again I have to compare the key value from this existing node, and this will inform me that you have to move left hand side because key value is less than root. Here new root become here, this become new root. So, I have to move the left hand side of this element 6, and finally the element 4 will get its required position. So, that is the way of inserting in a binary search tree. Now, next operation that is generally performed in a binary search tree is search. So, searching is a process of finding a required element from an existing binary search tree. So, to perform this we use an algorithm here. Here R denote the root and key is denote the required element which we want to find out. So, we make the first step first. If our root equals to null or key value is equals to a root value or root info, then we have to return the root value. And if we in the search operation we basically found the required element in the existing binary search tree. So, here we use R denote the root and key is element to be found. So, if the root equals to null or key value is equals to root info or root value, then we have to return with root. And if key value is less than root info, it means root value, then we have to move left hand side and we have to return, and we again call the research procedure root left and key, else we have to move the right hand side, it means a right subtree using the binary search operation or binary search procedure. So, root right hand side and key value. And we also can consider this algorithm using an example. Here we want to find the element 4 in the existing binary search tree. So, first I have to make comparison with the root. Here root is 8. So, 4 is less than 8, then I have to move left hand side, and when I go left hand side, or I found here the left subtree, and in this left subtree the root is 3. So, I have to compare element 4 with element 3. So, I found that 4 is greater than 3, then I have to move the right hand side, and in right hand side subtree I found the new node, new root is 6, and I will compare this with the 4, and he will move the left hand side because 4 is less than 6, then I will move the left hand side, and here I will insert, I will find the new element 4 here. So, that is the process of searching an element in the existing binary search tree. So our today lecture is finished here. Thank you.